Hello everybody, so this is a limiting reactant problem where we're going to determine what the limiting reactant is based off of two options and then see how many of a certain product we could produce based off of the limiting reactant that we have. So here we have how many grams of N2 can be made from 9.05 grams of NH3 reacting with 45.2 grams of copper oxide. So here is the equation given to us, and then so we're just going to start off by the reactants. We have NH3 and copper oxide. Some useful molar masses would be 17 grams per mole for ammonia, 79.55 grams per mole for copper oxide. So to begin with, in order to solve this type of problem, we have to work with moles, not grams. In this case, they have given us grams, and we want to convert those to moles because that's what you work with. So if you have 9 points, we want to find how many moles we have of NH3. So moles of NH3. If you have 9.05 grams of NH3, how many moles would that be? Well, we know here that NH3 is 17 grams per mole. So once you multiply that, so you have 1 mole on the top and then 17 grams on the bottom. And then, because your goal is to cancel out the grams, and then you would be left with moles. So once you punch that into the calculator, you should get 0.5316 moles of NH3. Okay, now moving on to the other reactant. Let's do that with a different color. So here we have, how many moles do we have of NH3? Well, we're given, did I say NH? How many moles of copper oxide? So we have 45.2 grams of copper oxide. But what's the conversion factor that we have to convert grams to moles? Well, if you look at this, we have 79.55 grams per mole, so we could put 79.55 grams on the bottom and then 1 mole in the top. And then the grams would cancel out, and then once you punch that into the calculator, you're going to be left with 0.568 moles of copper oxide. So now we have these two moles. Now we could work with the stoichiometry problem. But first, you want to determine which one is the limiting reactant. And how do you find that out? Well, so we have right here, let me put this on top. So if we said we have how much? 0.5316 moles of NH3, and then we have 0.568 moles of copper oxide. Okay. How many moles of what's the goal of the product? Our goal is N2. So how many N2s can we form if we have this amount of moles? Well, if you look at the equation, 2 moles of NH3 could yield, there's a 1 right here, 1 mole of N2. So if you have 0.5316 moles of NH3, and we know that there are 2 moles of NH3 for 1 mole of N2, the mole NH3s cancel out, so then you're just going to be dividing this number by 2 to get how many moles you could potentially make with this amount of NH3. So then once you plug that into the calculator, you multiply 0.5316 by a half, you're going to be left with 0.268 0.2658 moles of N2. For this one, same thing. You have 0.568 moles of copper oxide. How many moles of N2 could you make? Well, you see the conversion factor. There's 3 moles of copper oxide for 1 mole of N2. So you could just write 3 moles copper oxide for 1 mole of N2. The moles of copper oxide cancel out. You're left with moles of N2. So you're just going to be dividing that number by 3, and that would give you 0.1894 moles of N2. Now you see, what is the least amount of N2s we could make? And that would be this number right here. Therefore, copper oxide would be our limiting reactant. See, based off of the amount of moles we're given in the initial problem, we could create this. This is the maximum amount of moles of N2 we could create. Therefore, copper oxide would be the limiting reactant. And now, the problem just asks us how many grams of N2. We have moles of N2. That's a simple conversion. So if you have 0.1894 moles of N2, you could just multiply that by, well, how many grams are there in 1 mole of N2? We know that the mass of N is 14 when you look at the periodic table, but this is N2. So they come in pairs. So that means there are 28 grams per 1 mole of N2. The mole N2s cancel out. So you're just going to multiply 0.1894 by 28, and that number will be 5.303 grams of N2. And then, if you want to make this a little bit of a longer question, they would ask you how many grams of the excess reagent will be left. And I'll make another video about that in continuation of this problem.